In our discussion on interest, there are two terms that we will use pretty regularly. The word interest itself is simply the amount of money paid by some financial institution based on a certain amount of money that was deposited. It can also be used to describe the amount of money that you pay to a financial institution if you borrow money. So you put money in and you can earn interest, and you borrow money from that institution and you pay interest. The second term is principal, or another word for that is present value. The principal or present value is the amount of money that you either put into the account in the beginning or that you borrowed from the financial institution. There are basically two types of interest received from these accounts. If the amount of interest is based just on the amount of money borrowed or deposited for some fixed period of time, and it's not affected by any periodic payments, either putting more money in periodically or paying off part of a loan, then that interest is called simple interest. And it's probably good to sort of look at it graphically. You think of simple interest like this. Suppose you borrowed $100. That's the principal. After the first year, and we're gonna make the interest rate 50%, which is certainly not realistic, but it sort of lets you play with the numbers a little easier. So just pretend that the interest rate was 50%. If you borrowed $100 at a 50% interest rate, after the end of a year, you would owe $50 in interest. At the end of year 2, you borrowed $100, you owe another $50 in interest. At the end of year 3, you borrowed that $100, you'd owe another $50 in interest. So if you paid it all off, you'd pay back the principal plus those $350. At the end of 3 years, you would owe the $100 principal plus those $350s be another $150. You'd owe back $250. The way I think about simple interest is this. If you have a simple interest account, the interest that you receive on that principal doesn't earn any interest itself, or conversely, if you're paying it out as a loan, the interest accrued against you is not subject to interest charges. So with a simple interest, it's just flat. You borrow a fixed amount and you pay a certain percent of that fixed amount every year. The interest doesn't affect anything. That's a simple interest loan or a simple interest account, depending on whether you're borrowing or putting in. However, for most accounts, if you really go out and go to a bank or some financial institution, most of those accounts, the interest is actually factored in, and the model looks differently. In other words, the interest itself either earns or accrues interest. So if you deposit $100 and put in the interest that it earns back into the accounts, and that interest begins to earn interest itself. And so the model looks totally different. Just let's go back to that example with the $100 principal and the obviously unrealistic 50% interest rate. If you looked at it now in terms of what we're going to call a little later compound interest, you can see that after the first year, if you're paying 50% interest, which again is an unreasonable rate, after the end of the first year, you would owe, or if you're depositing, you would earn $50 in interest. So let's just stick with one or the other. Let's suppose we're depositing the money. So you put in $100 in the beginning. After the first year at a 50% interest rate, you will have earned $50 in interest. So now you have $150 in that account. Well, that $100 earns $50 the first year. It earns another $50 the second year, and it earns $50 the third year. But now we're looking at it differently. In the simple interest case, the interest never factored into anything. But with compound interest, the interest itself becomes part of the principal after it's earned, and it starts earning interest. So now that $50 that we earned after the first year earns interest also. So that $50 in year 2, you earn that $50 at the end of the first year. So after another year, which would be the end of year 2, the interest itself would have earned $25, and then that $25, that $50 would earn another $25 interest the third year. So the $100 was in there for 3 years, so it earned interest 3 times, 50, 50, 50. The $50 interest went into the account at the end of the first year, so it earned 25, which is 50% rate. Half of 50 is 25. It earned $25 interest the second year and $25 interest the third year. Now that that $50, that you earned interest on from the original principal, it's going to earn 50%. So that $50 will earn 25 going from the second year to the third year. And then the $25 that came from the interest on the interest of the first year, it earns 50%. Half of 25 is $12.50, so it'll earn a $12.50 interest rate. So you can see this is called compounding. It just builds up. So in the very beginning, you had $100. After the first year, you had $150. And then after the end of the second year, you had the $100 here. You had the $50 here. You have another 50, and you have another 25. So now you have even more in the account. And at the end of the third year, you have all those amounts added together. 100 and 50 and 50 and 25 and so on up the list. And so at the end of the third year, you would add up all of those numbers to find out how much you had in the account. So simple interest, the interest is just out of the equation. You get the interest, but it doesn't accrue any interest itself. With compound interest, the interest itself starts building up interest. And you can see that's the basic difference between simple interest and compound interest. So compound interest is interest which earns interest itself. Now, right now, we're going to put the compound interest aside and focus on simple interest. In part 2 of this discussion, we'll go back and focus on the compound interest. So first, I wanted to sort of contrast simple interest versus compound interest, but now I want to just focus on simple interest. And in the second part of our discussion, we'll focus on compound interest. So for the time being, just forget about the compound interest and let's focus on the simple interest. First of all, the formula you need to calculate the amount of simple interest is capital I is equal to capital P times little rt. Now, of course, if you don't know what those mean, then the formula does you no good at all. So you've got to know what these things mean. Capital I stands for the amount of interest earned. So going back to the very first example, that $100 earning 50% interest, that $50 it earned after the first year would be capital I if you were just putting in there for 1 year. Capital P stands for the principal or the present value. That's the amount that you put in initially, put into the account. Little r is the interest rate, and you always want to express that as a decimal. So, 8% would be 0.08, and 5% would be 0.05, and so on. And of course, little t is the time, and it always has to be expressed in years. If it's given in any other units, you have to convert that to years. And the best thing to do, I think, at this point is just to jump right into an example. Suppose we have $500 and we put it in an account that pays 6% simple interest. Remember, simple interest. How much interest will the deposit earn in 4 years? First of all, the formula. Capital I is equal to capital P RT. You've got to identify all the pieces. The amount that you deposit in the beginning is the principal or present value. That's the 500. So you can put 500 in instead of capital P. Then you notice that the simple interest rate is 6%. You want to write that as a decimal, so you move the decimal 2 places to the left, and that makes 0.06. That's R. So you replace that, replace R with 0.06. And then T is the time in years, that's 4, replace that. And so the amount of interest is simply the principal times the rate times the time. You multiply those numbers together. I won't always do this, but for some of these problems, I'll actually show the steps just so you'll get familiar with the calculator if nothing else. You'd do 500 times 0.06 times 4 and then hit equals. And you'll get 120. So the answer to the question is, if I invest $500 in an account paying 6% simple interest, I will end up with $120 in interest at the end of the 4-year period. Of course, I started out with $500 and I earned $120 worth of interest. Now, what if I want to know how much is in the account? Well, that's simple enough. If I started out with $500 and I earned $120 in interest, then of course, if you add the principal and interest, you'll get the amount in the account. So I have $500 plus $120, which is $620. So I start out with $500. 4 years later, I have $620. If the interest is 6% and it's simple interest. Now, the amount you have in the account, as opposed to just the amount of interest you earn, is called sometimes I call it the accumulated value, or sometimes it's called the future value. In other words, present value, the principal, is what the money is worth now, and later on in the future, you've accumulated more, and that's called the future value or accumulated value. So, to sort of summarize, if you want to know the amount of interest, you do capital I is equal to capital P times little rt. That gives you just the amount of interest. But if you want the total amount in the account, you have to take the amount of interest you earn and add it back to the principal. We'll call that capital A, and I always think accumulated value when I think of capital A. But it's another word for that is also future value. So the future value or the accumulated value is the principal plus the amount of interest you earn. Now you can rewrite that formula because I know that capital I is really equal to PRT. So if I take PRT and plug it in for capital I get P plus the quantity PRT. And notice there's a common factor of a P in both terms. So if I factor that P out, in other words, it's here and it's here. So if I factor it out, I'm just left with the understood 1 here, and I'm just left with the RT here. So I can rewrite the formula for an accumulated or future value of a simple interest account as capital A is equal to capital P times the quantity 1 plus little rt. Now that takes you directly to the amount of interest in the account. Remember, the first formula just gives you how much interest you earn. If you want to go directly to not just how much interest you earn, but actually how much do you have in the account, you can use that formula. Of course, you could always go to the first formula, calculate the interest, and add it back to the principal, but there's also a direct way. So this formula represents the direct way of going from how much you started with in the account to how much you end up with in the account. So it just depends on what quantity you want. That's which formula will be the best to use. But again, capitalize the amount of interest earned, and A is the amount of money in the account at the end of the time, which is the principal plus the interest, and it's called the accumulated or future value. So if we go back to that problem we worked in the beginning and change the question originally was how much interest will the deposit earn in 4 years. So let's change that, mark that out, let's change that to how much will be in the account in 4 years. Well, as you can see, we've already figured it out, but my point here is you can go directly to the answer by using this formula here. So let's do it that way. In other words, I'm giving you an alternate solution method that takes you directly to the amount in the account in case that's what you want. So we just plug in. We know that the principal is 500 from before. We know that little r is 6%, which is 0.06 from before, and we know that t is equal to 4 from before. So if you write the formula down and plug those values in, 500 goes in for P, 0.06 goes in for R, and 4 goes in for T. And do the calculation. Remember, your order of operations says do your multiplication first before addition, so you want to multiply 0.06 times 4. If you do that, you get 0.24, and then you want to add 1 to that, and so that gives you 1.24. That's when you add these two numbers. And then finally, you want to multiply through both the 1.24 by 500, and that'll give you 620. And notice that's the exact same answer we got earlier. My point here is you can go straight, you can use this formula to go straight to the answer you want rather than having to find the interest and then add back on the principal. Just another way of doing it, and that formula you'll find is going to be useful in some problems you'll be asked to work. Let's do another problem. Here, Alice needs $2,500 for a down payment on a car. How much would she have to put into a simple interest account paying 4% simple interest to have $2,500 in the account in 2 years? Now, this problem sounds similar to the other because it's a simple interest, but there is a little bit of difference because this time they're telling you how much she needs in the future. She's trying to save for a down payment on a car, so she needs $2,500 in the future. And we want to know how much she wants to put in now. So now, instead of solving for, knowing P and solving for A, we know A, and we're trying to solve P. So you've got to read these things carefully. She needs this money in the future for a down payment, so that's the future value. That's why I know that this is A. And they want to know how much you have to put in now. That's the principal, so we're looking for P. We still know what the little r and little t are, so we need to put those in. The interest rate is 4% simple interest, so as a decimal, little r would be 0.04. And the time is 2 years, so the t would be 2. And then, of course, you do your multiplication first. You're going to get 2 times 0.04, and that's 0.08. Then you will add the 1 and the 0.08, and that gives you 1.08. And then you're solving for P, so you need to divide both sides by 1.08. If you divide both sides by 1.08, you'll get P right by itself on one side. So P is $2,500 divided by 1.08. And again, use your calculator. I'm not going to show the steps. You'll get $2,314.81. So if Alice wants to save up for a down payment on a car and she needs $2,500 and she's going to do it 2 years from now, she needs to put $2,314.81 into that account so that she'll have the $2,500 2 years later. Now, up until now, we've talked about putting the money into an account, earning interest. Let's flip it now. Let's talk about what happens if you go to a bank and borrow money, and then you're paying them interest instead of you're paying them interest instead of them paying you interest. That's called a simple interest loan. It works pretty much the same way, except the roles are reversed. But let's look at it that way. We have enough information to do these simple interest loans. The thing you've got to realize is that most consumer loans out in the world are not simple interest. So we're going to do this more as an exercise and just seeing how it all works, because you'll find if you go out to a bank that you're most likely going to be offered a compound interest loan. So we're doing these simple interest loans sort of as a preliminary, and they're a little bit simpler than the compound interest loans. So it's sort of good to start with a simple. Later on, after we talk about compound interest, we'll also talk about compound interest loans, which are the common ones you see out at financial institutions. Anyway, the best way to do this is just an example because you have all the tools you need already to do these problems. So here's our example. I want to compute the monthly payment for a simple interest loan of $2,090 if it has an annual interest rate of 8% and a 5-year term. Now it says it's a simple interest loan. So I know that I'm using the simple interest formula in some fashion. But before we actually jump into it, let's talk about what strategy we're going to use here. Because these simple interest loans have no compounding interest, in other words, thinking back to the earlier diagrams, the interest never earns interest. So it's much simpler. All I need to do is find out the future value of the loan, or the accumulated value of the loan, and then divide it by the number of payments you're going to make over the period of time that you borrow the money. In other words, the bank is not going to charge you interest on the interest accrued with a simple interest loan. So you don't have to worry about it. All you've got to do is figure out how much you owe them in the end and divide it into equal payments. Now, these are monthly payments, so if you borrow it for 5 years monthly, you've got to consider that. But all in all, it's pretty easy. You figure out how much you're going to owe in the end and divide it into the payments based on how many times you'll end up paying them over that 5-year period. So pretty simple in theory. So let's do that. So the first thing I want to do is find capital A, the accumulated value, what I'm going to owe the bank in the future. After that 5-year period, what will I owe the bank? Well, I know the formula for that. We just talked about it. I know that I'm borrowing $2,090. That's the principal. That's the present value. What I am starting out owing. Plug that in. The interest rate is 8%. That's as a decimal 0.08. Plug that in. And then it's a 5-year term, so T is 5. Do your multiplication first, so you multiply 5 times 0.08, that comes out to be 0.40. Then you do your addition, and that comes out to be 1.40, and then finally you multiply those two numbers together, and you'll find out that in the end, at the end of 5 years, you will owe the bank $2,926. Now, you're paying it over a period of time, so you've got to divide it up by that amount. So how many payments will you make? Well, that's actually pretty easy. It says you're doing it monthly, so that means you're paying 12 times a year and you're doing it for 5 years. Well, if you pay something 12 times a year for 5 years, you've made 60 payments. That's what's so nice about simple interest loans. You don't see them very much, but they certainly are easy to calculate. Once you know the future value, you just divide it by how many times you have to pay it back. So the final step is to say, well, the monthly payment is just the future value, or accumulated value, capital A, divided by the number of payments that we just calculated in step 2. So that's $2,926 divided by 60, and that comes out to be $48.77. So if you borrow $2,090 at 8% simple interest for 5 years, that will generate a monthly loan payment of $48.77 back to the bank each month. We looked at this particular problem to understand the process, but now that I've done it with a particular problem, I do want to go back and summarize how it works in general, just to make sure we've all got it. So in general, when you're going back and doing this, what you're going to do to calculate the monthly payment on a simple interest loan is, number one, find capital A, find the future or accumulated value using the formula that we've developed for simple interest loans. Then you find the total number of payments that are due over the term of the loan, and that's simply, if they're monthly payments, that's 12 times the number of years of the loan. Now, if it's semi-annual payments, it's 2 times the number of years alone. But generally, for the things we'll be doing, it'll be monthly payments. But that 12 is there only because it's monthly payments. And finally, to actually calculate the monthly payment, you take the capital A you calculated in step 1 and divide it by the number of payments that you calculated in step 2.